Today in this lecture we will see moment of inertia of laminas passing through centroid of different cross sections like rectangle, square, triangle, right angle triangle or circle. First see moment of inertia of rectangular cross section is x-axis, x-axis and this is y axis, and rectangle is at centroid of this x and y axis. That means is this x and y axis are passing through centroid of rectangle. This is B and this is D. V D. So here Ixx moment of inertia about x axis is B d cube by 12. See moment of inertia about x axis, and this breadth B is parallel to this x axis, B d cube by 12, and moment of inertia about y axis is I y is equal to, see this y axis and parallel to this y is this d side, so this d and b cube by 12. For consider this d as 2 meter and b as 4 meter and calculate Ixx and Iyy. Ixx is 4 into 2 cube, b is 4 and d is 2, 4 into 2 cube 32 divided by 12, that means 2.67 meter raised to 4. Unit of moment of inertia is meter raised to 4, and this Iyy is d into b cube by 12, that means 4 into 2 cube by 12, 4 into 2 cube by. This is also similar, 2.67 meter raised to 4. So now take these dimensions like this d is 0. See this d is 2.3 meter and b is 4.5 meter and calculate Ixx and Iyy. Ixx is 4.5 into 2.3 cube divided by 12 is 4.56 meter raised to 4, and 4 point here d is 2.3 into p cube is 4.5 cube divided by 12, 17.46. Here Iyy moment of inertia comes bigger. That's why in beams we provide this y-axis perpendicular to loading. Now next is square section. This is square, this is centroid x and y. This side of square is a and this side of square is also a. So here Ixx is equal to a raised to 4 Ix, this moment of inertia about x-axis, and this parallel to this x-axis dimension is this a raised to 4 by 12, and Iyy is equal to this moment of inertia about y axis parallel to this y, this a raised to 4 by 12. So in square, moment of inertia about x axis and y axis is same. Both moment of inertia are same. In square circle, moment of inertia about x axis and y axis are same because their dimensions are also same. Cross sectional dimensions are also same, so moment of inertia is same. Now next, so see here, moment of inertia is directly proportional to a. That means if we increase this a side of square, that means if you increase dimensions of square, there is moment of inertia also increases. Now triangle, isosceles triangle, laminas passing through its centroid. See here centroid xx and here yy. This y, this y, and this is height h. And this is b. And up to this distance is here this point is, this is 1 by 3, that means h by 3, and here up to this is b by 2, this b by 2, and this is also b by 2. Now Ixx, here moment of inertia about x axis parallel to this xx is b. This b, write b as it is, this height h cube, b h cube by 36, and Iyy is equal to, parallel to this Iyy is this h side, h b cube by 48. Here Ixx is bh cube by 36, this 36, and Iyy is bh cube by 48. This h is bigger than b. See, sorry, h is not. Ixx is bh cube by 36, Iyy is equal to hb cube by 48. For isosceles triangles, moment of inertia. Now next is right angle triangle. This XX and this YY. This is height of triangle, right angle triangle, H, and this is B. IXX is equal to IXX parallel to this XX is B. B as it is H cube by 36, and IYY is equal to IYY parallel side is H B cube by 36. Now next is circle. Let this is circle of centroid center XX and vertical YY. And capital D is diameter of circle. IXX is equal to pi d raised to 4 by 64, and IYY is equal to pi d raised to 4 by 64. Moment of inertia for circle, both moment of inertia IXX and IYY is same because diameter is same, and here also sides are same, that's why IXX and IYY for square are same. Here for rectangle, cross section BD is different, that's why moment of inertia are different. Triangle, for triangle also moment of inertia along XX YY different, and for right angle triangle also different. So for rectangle, moment of inertia about XX axis is BD cube by 12, and moment of inertia about YY axis is DB cube by 12. For square, moment of inertia IXX is A raised to 4 by 12. Moment of inertia about IYY is A raised to 4 by 12. For triangle, moment of inertia about IXX is BH cube by 36, and IYY H B cube by 48. Here 36 and 48, remember this. For right angle triangle, moment of inertia about x axis is BH cube by 36, and IYY is HB cube by 36. And for circle, both moment of inertia about x and YY axis is pi d raised to 4 by 64. Thank you very much.